Here we go. We have a question, maximum value sum by placing 3 rocks part 2. So I will tell you the solution and the solution will work for the part 1 and part 2. You have given M cross N 2D array board representing a chessboard where board ij means cell. The current cell represents the value of the cell ij. Rock is the same row or column attack each other. You need to place 3 rocks on the chessboard such that the rock do not attack each other, and we have to return maximum sum. So we have a grid and we want to place 3 rocks only. This is important. We want to place only 3 rocks and we can place on any cell. Suppose I place a rock here, then on the next row, as I have placed rock on this row, so I will jump to next row. In this row, so I will check, can I place my rock here? So it will tell me I cannot place rock here, so I will place my rock here. On the next row, I will place my rock here. So this is one configuration. Another configuration is I place a rock here, here and here. This is another configuration. Next we have I place a rock here. Actually I place a rock here, then I will place here, then here. This is also valid. Then one here, second here, then third here. Third I can place here also and here also. So there are a lot of configuration and we have to find the maximum sum. So whenever I place a rock, we will get the current cell value. So we want the maximum value. In this example, if I place a rock here and second here and third here, then we got answer as 4. So we want the maximum value. For this configuration, I have 1, 2, 3, 4, 5, 6 and on the second row we have 7, 8, 9. So if I place a rock on 0, 0 index, then 1, 1 index, then 2, 2 index. So we have value 1, then 5, then 9. So its total is 15, and in this the maximum I have is 3. So here we have some constraints. So let's build the approach. I have a grid and I want to place only 3 rocks such that our resultant is a maximum. So here we have n cross m matrix. Maximum n value is 500. So suppose it is 500 cross 500 matrix. So I cannot take all the configuration. I have to maximize it somehow. So as this is given, we have to maximize it. So that's where priority queue comes. So we have a priority queue, and in this priority queue I will store an array. So here I have to store something. So something is ij, means I will iterate and I will store ij and the value. Value is current cell ij, ai and j. So let's suppose I stored my values like this, aij, then I and j. So the value is on 0th place, my row number is 1th place, and column number is on 2nd place. And we want maximum cell value. So we will sort this priority queue. So we will apply. So we will apply a comparator. In this comparator, we have some values in our priority queue, and we want topmost value. Our topmost value is the maximum cell value. So how to do this? we have a value here. So this is an array, and second value here, this is also an array, and on zeroth place I am storing cell value. So what will I do? B of 0 minus A of 0. So that's it. Then priority queue have all the values in descending order, and it will sort according to the cell value. So on topmost, our topmost value is the maximum value. Our topmost value is the maximum value in a priority queue. So we have some values. Suppose I here, j here. So we want to place 3 rocks on different places, so it will not attack each other. Suppose I place a rock here, so this column and this row is booked. So second, I have to place a rock here, so this column and this row is booked. uh, Let me use another color. So this row and column is booked. If I place second row here, so this row and column is booked. If I place third row here, before that our third maximum value is this. So we have to check, can we place a row here? So it will tell me no, I cannot place. So I have to find fourth largest value. So it will check, can I place a row here? So it will tell me yes, I can. So we have some rocks, actually 3 rocks. We want to place 3 rocks. Suppose this rock, the first row index is A and B. Second row index is I and J. Third row index is X and Y. So I want this, and this to be different. So if X is equal to I, means I have placed a row on same row. So I cannot place. If this value is true, or A is equal to X, if this value is true, means if I have to place third row, it tells me that third row, this row is already booked by first row, so I cannot place. Or I is equal to X. Same goes for Y indexes. If B is equal to J, or B is equal to Y, or B actually J is equal to Y. So this is not a valid configuration. For this we will continue. Else we have some value I, AB, IJ and XY. So I can place my row on these indexes. So this is a valid configuration. So from the total configuration is this, which is 225 cross 10 raised to power 4. So I don't have to build all the configuration. The topmost the topmost 15 topmost 15 values will work fine. Topmost 15 values will work fine. So I have a priority queue. So I will convert my priority queue in a list, and in a list I have to place, in a list I have to traverse and want to place 3 rows. So I have one for loop, second for loop and third for loop. So it will tell me my first row id1, it will tell me id2, and it will tell me id3. So id1 contains these values, so cell number and column, row and column. Same for second row, same for third row. So we have some rows and column. If we have already placed on same row or same column, so we just continue. Otherwise we place, we assume, we visualize it that we placed the row, but actually we don't need to place it. We will just get our value. The value is present on the 0th index. So we take our values from id1, id2 and id3. So after calculating all the values, all the topmost 15 values, we will return our maximum answer. So let's code this. First I have a priority queue. It is a it's a descending, order. Next we have n, m and answer. So the values can be negative. Yes, the values can be negative. So I have to take the minimum value. So it is long, I have to take long minimum. Next, just traverse into your matrix and fill your priority queue. After filling priority queue, we have to fill the priority queue values into a list. So suppose here I said we need only 15 values, but the minimum configuration is this 9 cross 3 cross 3. So either we need 9 values or we need 15 values. Either we need 9 values or we need 15 values. If this cell is low, if a cell is less, so priority queue only contains 9 values. So either we take this value, either we find the size. So priority queue size is 9. So either priority queue size, so let's say n or 15. So whatever is minimum, I will take. So first to find your size, priority queue size. Next, we have to find the minimum value, minimum between size and 15. Next, fill your list. After filling the list, we have to place 3 rows. So id1 represent row 1, id2 represent row 2, id3 represent row 3. So AB is the row 1 position, ij row 2 position, and xy is row 3rd position. On the 0th value we have on the 0th index we have value, and on the first index we have row number, on the second index we have column number. After this, if row number is same or column number is same, so we will just continue, otherwise we will take the summation. So this is integer, so I have to first convert into a long. So just take out the cell value. So id1, id2 and id3, it represent row 1 position, row 2 position and row 3 position. We have to take values, and we have to update our answer variable. So answer represent the maximum value. After this, just return your answer. Let's submit this. And in between, let's talk about time and space complexity. So we have a priority queue, and priority queue contains all the values. So its space complexity is n cross m. So if we talk about time complexity, we are adding our values into a priority queue. So adding or insertion in priority queue takes log n time. So here n represent the size. So here size is n cross m, and we want to fill n cross m values. So its time complexity is n cross m log n cross m here. Next, we are just removing the values. It is the same thing. Next, we are iterating. So here the maximum we have is 15. So it's 15 cross 15 cross 15, and that's it. I think my internet is a bit slow. And we have solved this question. If you have any doubt, feel free to ask in the comment section, and click on the like button and subscribe button. Thank you all for watching.